with. Now, this idea gets glossed over quite quickly, but it kind of ties in with like trapezium rule and stuff you've seen before. An area under a curve can be thought of as loads of little strips of area, okay? And the more strips you take, the closer to the true area they'd be. So it's almost like an infinitely small strips all added up would make that area. And the more you take, so this is where it ties in with limits. So as the width of these little rectangles or trapeziums get narrower, it would actually get closer to the true integral. If you haven't seen this before, please make a note of this, because some of the examples put this question in the exam with this sigma notation before, and no one knew what to do. And all it means is literally integrate it. Okay, so if they asked you to do this for this function between 5 and 2, you just turn it into this. It's just not letting that notation throw you off. Okay, so this is where people got all in a big flap and they were like, it's not worth loads of marks, but I don't actually know what it means. Let's do the limit of the sum of the function with respect to these little small changes. All it means is integrate it between those bounds. So it's just like not letting that notation phase you is what we're getting at. So all we're doing is we're recognizing integration as a sum of little areas. So the limit of a sum of rectangles, let's say, from A to B, which are x bounds. Okay, that's all this is. And we're just adding these areas up. And that's as we shrink the width, as these get smaller and smaller, it will fill up that area more perfectly. And ultimately, it will represent that integral. Okay, so that is a really important point to make, as that notation has thrown people off in the past. Right, let's keep pushing on. So this one here, so looking at this question, therefore the integration of a function gives the area between the curve and the x-axis between those limits. So this is another thing to remember. When you're doing an area, you don't put plus c, because first of all, it's a subtraction, so the c's would cancel anyway, but also that's a different use of integration. It's for a different mechanism. So if this is between B and A, and remember we want to denote this properly, this would be f of B subbed in minus f of A subbed in. So even if you had the constants in there, they would cancel anyway. So the better convention is just not to write the plus c for this kind of question. And that will evaluate the area underneath. Now also,